All right. Today we are going to begin a unit on factoring. Okay, so today we are going to talk about factoring using the greatest common factor. Okay, so that's primarily what we are going to practice today. Okay, so the greatest common factor I want to go ahead and define just really quick. So that is the largest, or in other words, greatest factor that two numbers or terms have in common. The largest factor that two numbers or terms have in common, greatest common factor. Okay, so in order to practice this, I'm actually going to have us turn to the back of our notes page. And yes, you can tell it is handmade by me. Okay, did this to match the assignment that you guys are given. So it says, find the greatest common factor of the two terms given. Sometimes you're just given two numbers. Then we're going to talk about where you're given actual like terms with a coefficient and some variables attached. Okay, so our first one, we want to find the greatest common factor between 15 and 35. So what we are going to practice doing is just create some factor lists. So 15 and 35. Okay, so I'm going to give myself some T-charts here, okay, to create some factor lists of, sorry, the camera's kind of shaky. Create some factor lists for the number given. So for 15, I know that 1 times 15 gives me 15. Okay, I also know that 3 times 5 gives me 15. Okay, well 4 doesn't go into 15, 5 does, and we already have it on our list, so we're done with 15. Those are all of our factors of 15. Okay, same thing for 35. 1 times 35. 2 does not go into 35. 3 does not go into 35. 4 does not, but 5 does. 5 times 7. Okay, 6 does not, 7 does, and it's on our list. Okay, so we are done. Once you start going back up the list, then you are done. So now what I'm going to do is find the biggest number that appears on both of these lists. Okay, well I know that's going to be 5. So my GCF for these two are 5, or is 5, excuse me. Boom. Okay, awesome. Let's practice that again. Okay, so I'm going to do the same thing here. So I have 27 and 33. I want to find the greatest common factor between 27 and 33. Okay, well for 27, I have 1 times 27. 2 doesn't go into it, 3 does. 3 times 9. Okay, 4 doesn't, 5 doesn't, 6 doesn't, 7 doesn't, 8 doesn't, 9 does. We already have it, so we're done for 27. Okay, now for 33. 1 and 33. 2 does not go into it, 3 does go into it. 3 times 11. 4 doesn't, 5 does not, 6 does not, 7 does not, 8 doesn't, 9 does not, 10, no, 11, yes, we already have it, so we are done with our lists. Okay, so find the number, the biggest number that appears on both of these lists. Okay, well that is going to be 3. So our GCF is 3. Beautiful. Okay, let's practice that a couple more times. So now I have 21 and 81. 21 and 81. Okay, well I know for 21, 1 times 21. 2 doesn't go into it, 3 does. 3 times 7. 4 doesn't, 5 doesn't, 6 doesn't, 7 does. We already have it, we're done. Okay, now for 81. 1 times 81. 2 doesn't, 3. Oh gosh, I should have brought a calculator. You guys probably can do this in your head faster than I can even. Okay, so 81, I'm pretty sure 3 goes into 81. So I'm gonna do 81 divided by 3. And yes, it does. Feels so dumb, I did not bring a calculator. 3 times 27. Okay, well 4 doesn't, 5 doesn't, 6, I'm just gonna check. 81 divided by 6. It doesn't, it gives me a decimal. Okay, 81 divided by 7 definitely gives me a decimal. 81, 8 definitely doesn't. 9, yes, I do know that one. I knew that one in my head. 9 times 9. Okay, well now we see that we're already starting to go back up our list. So we're done for 81. Okay, now I need to find the greatest common factor that appears on both of these lists. Okay, well that is going to be 3. So even though these two numbers were pretty big, our GCF is a small number. It is 3. Beautiful. Okay, let's go ahead and practice where we're just using numbers, just integers one more time. Okay, so I have 36 and 100. Okay, so for 36, 1 times 36, 2 times 18, 3 times 12, 4 times, I believe that's 9, but I'm gonna double check. 36 divided by 4 is 9. Yep, I knew that. Okay, 5 doesn't go into it. 6 does. 6 times 6. And again, now we see we're starting to go backwards because 6 is multiplying by itself. So we're done. Okay, now for 100. 1 times 10. 2 times 50. 3 doesn't go into it. 4 times 25. 5 times 20. 6 doesn't go into it, 7 doesn't go into it, 8 does not go into it, 9 no, 10 and 10. And boom, I thought it was going to be longer than it was. Okay, so now find your GCF. I always like to start with my big numbers, see if they have any in common. 36, no. Okay, and it looks like my greatest common factor here, again, two large numbers, our GCF is relatively small. We have a GCF, greatest common factor, of 4. Beautiful. Okay, so now let's go where we're still given two terms, but this time these terms have a coefficient and then some variables. Okay, so the first thing I'm going to look at are just the coefficients, 4 and 12. And if you want to make yourself some t-charts, feel free. Okay, this helps me organize it and actually see the number that's biggest on both lists. Okay, so 1 times 4 and 2 times 2 are my only factors of 4. 12, 1 times 12, 2 times 6, and 3 times 4 for 12. Okay, well now I can find the greatest common factor, and that is going to be 4. Okay, so I know in my final answer, I'm going to have a 4. Okay, but now what I need to look at are my variables. Okay, so the first variable I'm going to look at are my x's. Okay, so my first term has x squared, or just x times x. My second term has 5. X times x times x times x times x. Okay, now what you're actually asking yourself is how many x's do they have in common? Or in other words, how many x's do they both have? Okay, well my first one had 2, and this one has at least 2. Okay, so this means they have at least 2 in common. So in my final answer, it's going to be x squared. Okay, and now for my y's. So I have 1 y there, 4 y's there. So my first term has just 1 y, my second one has 4. Okay, well how many do they both at least have? They both at least have 1. So in my final answer, just 1 y. Okay, now here's the shortcut. Here's the tip with variables. Okay, and I'm gonna actually write this on our paper. With the variables, finding the greatest common factor between two variables is just take the lesser amount of variables. And what that means is, so my first term had 2, my second term had 5 of x's. Well, I'm just going to take the least amount of my x's, 2. For y's, the first term had 1 and the second term had 4. Again, take the least amount, which is just 1. So my final answer, my GCF, is 4x squared y. Beautiful. Okay, so let's try that one more time. Okay, so again, I'm just going to start with my coefficients, 14 and 21. Okay, let's give ourselves our t-charts to find the greatest common factor. 14, 1 times 14, 2, and 7, 2 times 7. 3, no, 4, no, 5, no, 6, no, 7, yes, we already have it, so we're done. 21, 1 times 21, 2, no, 3, yes, 3 times 7. 4, no, 5, no, 6, no, 7, yes, we already have it, so we are done. Okay, well, the GCF between these two would be 7. So in my final answer, I know I'm going to have 7 as my coefficient. Okay, now I need to look at my variables. This time we have 3 variables, x, y, and z. Okay, so I'm gonna look at my x's. So this one has 6, this one has 2. Let's go ahead and just use our shortcut. Take the lesser amount. Okay, so that means I'm going to take 2 in my final answer. They both at least have 2. Okay, do the same thing for your y's. This term has 2 y's. This one just has 1 y. Take the lesser amount. I'm going to take 1 in my final answer. They both have at least 1 or 1 in common. Okay, and finally, now I'm going to look at my z's. First term has 3. Second term has 4. I'm going to go ahead and take the lesser amount, which is 3. So z cubed. And my final answer, GCF between these two terms, 7x squared y z cubed. Beautiful. Okay, so now that we practice just with 2 numbers or 2 terms where variables are involved, let's go ahead and factor some binomials. Okay, remember binomials are an expression with 2 terms. Okay, so I'm going to go ahead and zoom in just a little bit so you can see it maybe a little better. Okay, so when I'm factoring 2 binomials, so again, first thing I'm going to look at are just the coefficients, 6 and 15. Okay, and again, if you want to give yourself your 2 t-charts, go for it. Okay, so 6 and 15, sorry, zoom out, it was a little close. 6 and 15, 1 times 6, 2 times 3 for 6. For 15, 1 times 15, 2's no, yeah, 3 is yes, 3 times 5. Okay, so out of the coefficients, my greatest common factor is 3. So here's how we're going to write this, because it doesn't just want the greatest common factor, we want our final answer to actually be an expression. Okay, so since my greatest common factor was 3, we're going to take a 3 and put it on the outside. Okay, and you're like, the outside of what? Okay, we'll get there. So now what we're going to look at are the variables. My first term has 1b. My second term doesn't have any b's. So I cannot take a b out if they both don't have one. Okay, so here's what we have to do now. So you said outside of what? Well, inside our parentheses is everything that's left inside. The only thing that we could take from both of these terms is that positive 3. Okay, well now to figure out what's left inside, we're going to divide. That's what factoring is division. So I'm going to take 6 divided by 3. Okay, well that's going to give me 2 with my b attached. And then I'm going to take negative 15 divided by 3. Well, that's going to give me negative 5. Okay, and there is my final factored expression, where I was able to take the GCF out, and inside my parentheses is what was left over when I divided that GCF. Okay, let's go ahead and do that again. For number 2, look at your coefficients first. I have negative 8, positive 20. Okay, and it's okay that it's a negative 8 here. We're kind of going to ignore it just at the beginning. Okay, but for 8, I have 1 times 8, 2 times 4. 21, 20, 2, 10, 3, no, 4, yes, 5, yes, 4 times 5. Okay, so my GCF out of these guys is going to be 4. So I know 4 is able to come out of this expression. It's going to be my GCF. GCF is always outside of the parentheses. Okay, well now I have variables I have to look at. X to the 5th and x squared. Same rules apply here with variables. Take the lesser amount. The lesser amount is what can come out. So x squared is able to come out. Okay, well that's our GCF. And now we need to figure out what's left inside by dividing this out. Okay, so my first term, when I divide by 4x squared, okay, negative 8 divided by a 4 is going to give me negative 2. And then if I had 5 x's there, but I took out or I divided 2 of them out, I'm left with 3. Right, those are our exponent rules when it comes to variables. Same thing for my second term. 20 divided by 4x squared, well 20 divided by 4 is going to be a positive 5. And I had 2 x's, but I divided both of them out, so they cancel out. There's no more x's left on that one. And there is my final factored expression, where the GCF is out front. Awesome. Let's go ahead and just keep practicing this. Okay, so this time I have negative 25 and 20. Negative 25 and 20. Okay, well 25, 1 times 25, 2 no, 3 no, 4 no, 5 yes, 5 times 5. We're already starting to repeat, so we're done. 20, 1 times 20, 2 times 10, 3 no, 4 yes, times 5. We're done. Okay, GCF on both of these lists is going to be the 5. Okay, so I can take out a 5. Okay, now we need to look at our variables. Okay, and actually with this 5, here's what I'm going to do. I can actually take out a negative from both of these. Okay, I can divide a negative by a negative, and there's also a negative that can go into a positive. Okay, so I'm just going to take out that negative 5. Okay, so now I need to look at my variables. First term has 3, second term has 1. Take the lesser amount. Okay, take 1. 1 can come out. Let's figure out what's left inside when I divide out my GCF. Now I'm going to take both my terms, divide by my GCF, which is negative 5x, divide by negative 5x on both terms. Okay, negative 25 divided by negative 5 leaves me with positive 5. 3 x's, taking 1 away or dividing 1 out leaves me with 2 x's. Okay, my second term. 20 divided by a negative 5 leaves me with negative 4. I had 1 x, but I divided it out, so there's no x's left. And there is my factored expression. GCF out in front. Beautiful. Let's keep going. Number 4. I have negative 15 and negative 9. Negative 15, negative 9. Okay, I'm not going to worry about the negatives just yet. Okay, so 15, 1 times 15, and 3 and 5. 9, 1, 9, 3 times 3. My greatest common factor on both of these lists is 3. So 3 will be part of my greatest common factor. Okay, well now I look at my variables. My first term doesn't have a variable, my second term does. I cannot take a variable if they both don't have one. Okay, so now I can just go straight into what's left inside. 3 was my only GCF. Okay, well, since both of these terms are negative, I'm actually going to make that a negative 3. So I'm going to divide both of my terms by negative 3. Negative 15 divided by negative 3 leaves me with positive 5. There were no m's, so we're good. Negative 9 divided by negative 3 leaves me with a positive 3, and I had just that one m left attached. And there's my final factored expression. Beautiful. Alrighty, 2 more. Okay, so my coefficients. I'm looking at 8 and -4. 8 and -4. Okay, well 8, 1 times 8, 2 times 4. -4, well, don't really care that it's negative right now. 1 times 4, 2 times 2. Okay, my GCF between these two coefficients is 4. Okay, but because, well, I'm going to leave it as +4. Okay, the reason I'm not going to take out that -4 is because my leading coefficient, the one in front, is positive. So I'm just going to go ahead and keep my GCF as +4. Okay, now I look at my variables. M cubed, M squared. First term has 3, second term has 2. Take the lesser amount, M squared. Now let's figure out what's left inside when I divide out my GCF. 8m cubed divided by 4m squared. 8 divided by 4 is 2. 3 m's dividing away 2 m's leaves me with 1m. Okay, now my second term. -4m squared divided by +4m squared. -4 divided by +4 is -1. M squareds, dividing all of the m squareds out, I am not left with any m's. So there is my final factored expression. Beautiful. Okay. Last one. Ooh, and this is kind of the same thing. Okay, so since I have the same coefficients here, I'm just going to refer back to this list. So we know that 8 and -4, which is exactly the same, 8 and -4. My GCF was +4. That's great. I don't have to do more work than I have to. 4. Okay, well now I look at my variables. My first term does not have a p. My second term does, so I cannot take any p's. Okay, and before I move on, just like I talked about on the last one, since my leading term, the one in front, is negative, I'm actually going to take out a negative. Okay, well now I just need to figure out what's left inside when I divide out my GCF of -4. -4 divided by -4 is +1. No p's attached. 8 divided by -4 is -2. Didn't take away any p's, so that p cubed is still attached. And there we go. Okay, the last thing I want to show you on this video is the fact that factoring is just the opposite of the distribution. Okay, so distribution we know is multiplication. So let's say I take this expression, -4 times 1 minus 2p cubed. Since we factored it, we are dividing. Well, let's see what happens when I use the distributive property to go forwards, or to go the other way. -4 times 1 is -4. -4 times -2p cubed, well, negative times a negative gives me a positive. 4 times 2 gives me 8, and attach my p cubes. Okay, that's the exact same expression we started with. Okay, so factoring is the opposite of distribution. Factoring is division, distribution is multiplication. Okay, awesome.